So we're going to spend one more day on this section, 6.7, solving radical equations and solving radical inequalities. This is actually easier than yesterday's worksheet. I think it's good practice, but it's not the best practice for what you're going to see on Friday's test. For the best practice, I recommend looking at the examples in the book. But right here, on the first half of this worksheet, you have radical inequalities, or radical equations, not inequalities. And radical equations, go ahead and pick one, 1 through 16. Which one should we look at? 5? Okay, so if we take a look at 5, step 1 on solving a radical equation is to isolate the radical. Okay, now you're probably thinking, well, there is no square root. There is a square root. Where's the square root at? It's right here. It's the square root of y, right? The power of 1/2 is really the square root of this value y. Now, this is a great problem to pick. Why is that? Because the 1/2, the power of 1/2 only belongs to y. Okay, it does not belong to the 3. So a lot of people get confused with that. If you want, go ahead and rewrite it as a radical as opposed to a rational exponent. So just to make things a little bit easier to see, let's put, instead of the power of 1/2, let's put the square root of y. Do we all agree with that? That -3 is really being multiplied by y to the 1/2 power, which is really saying -3 times the square root of y equals 25. Okay, now step 1 on solving these guys is to isolate the radical. Right, Jasmine? Isolate the radical. You want to get the radical by itself. So I need to get rid of everything except for the radical. You see, here's the equal sign. The radical's on the left side of the equal sign, but I need to get rid of all this stuff. So what do I get rid of first? Michelle, what do you say? Get rid of what first? The 18. We're going to subtract 18 to get rid of it. Okay, so I really have now a -3 times square root of y equals 7. Thank you. Final step would be to do what? Yeah, to get rid of that multiplication of -3 by dividing by -3, dividing by -3, and we will have the square root of y equaling 7 over 3. You could put the negative out here in the front to make it look like a negative fraction instead of a -3 on the bottom. Okay, so step 1 is to isolate it. We've already isolated it. Step 2 is to get rid of it. Okay, so you get the radical by itself, and then you get rid of the radical by applying a power to both sides. So what power am I going to use to get rid of the square root? Right, this is a square root, so I'm going to use the power of 2. If it were a third root, I'd be using the power of 3. If it were a fourth root, I'd be using the power of 4 on both sides. If it were a fifth root, I'd be using the power of 5 on both sides. So once again, whatever your root is, you're going to do that same value of the root, and you're going to put it as a power, because the power will undo the root. So what you do to one side, you do to the other side. Okay? So again, the square root, we're going to get rid of it by doing the square. And now I have a nice, beautiful y equaling -7/3 times -7/3, which is a positive 49 over 9. So there's your answer. Y equals 49 over 9. Now, you do need to double check it and make sure that you don't get an extraneous solution. So when you plug in the fraction 49 over 9, you really have the square root of 49 over 9, which is really doing the square root of the top and the square root of the bottom. So maybe on this one I will show my work. I usually just talk you through it, but it might be a little confusing. 18 take away 3 times, let me put the 49 over 9 right here, and it is to the 1/2 power, and it should equal 25. So this is my checking my work part. Okay, so when I do the square root of the fraction, it's really the square root. So I don't have to put the power of 1/2. I could do the square root of the whole thing, which means I want to do the square root of 49 over the square root of 9. The square root of 49 is 7. The square root of 9 is 3. So what do I have left? I still have this multiplication of -3. I want to keep that in parentheses. I still have the 18 out here in the front. I still have the equals 25. Let's see if it actually does work. The 3 times 7/3, the 3's cancel. So I'll end up with 18 minus 7, right? 18 minus 7. So what is 18 minus 7? It's definitely not 25, huh? So this answer is an extraneous solution. I would put a line through it and just say no, as in no solution. And if you check the answer in the back, number 5 should have this, a no solution symbol, or it should say no solution. Okay, so this is a great question that you guys asked, because it's an example of where we did all the work correctly. We got an actual answer, 49/9, but when we tested it, even though we had a nice answer, it didn't give us a true statement. That was an extraneous solution. That's not going to happen all the time. It's not even going to happen most of the time. It rarely happens, but it does happen where you get a nice answer, you plug it in, it doesn't work, it's a no solution problem. So the whole first half is exactly that. Isolate the radical and then get rid of the radical by applying a power on both sides. So on number 10, what would I have to do to isolate the radical? Subtract 2. On number 3, what would I have to do to isolate the radical? Divide by 5. On number 2, what do I have to do to isolate the radical? Subtract 3. So you guys see that first step of isolating the radical? Right? On number 8, what do I do to isolate the radical? It's already isolated. Right? It doesn't have a times 5 out here. It doesn't have a plus 7 at the end. It's already isolated. It's already by itself on the left side. Right? So step 1 is to isolate your radical, whatever it may be. Right? Number 11, how do I isolate that radical? How do I isolate that? Add 1, that's right. Number 10, how do I isolate that radical? Subtract 2. Okay, so that is step 1, to isolate the radical. Step 2 is to get rid of the radical by applying a power on both sides. So number 9, it's already isolated. What power am I going to apply on both sides? Yeah, the third power. And then you just solve it the way you normally would. Okay, and don't forget to plug in your answer to double check it. So once you've isolated it, like after I divide by 5, okay, it's isolated. What would I have to do to get rid of that radical? What would I have to do? Yep, power of 2. So again, I don't want to do each problem for you, but I do want to just get you used to, okay, I need to isolate the radical first, and then once it's isolated, I need to get rid of that radical by applying a power on both sides. You guys get it? Yay? Okay, and of course, check your answer. Now, when you get down to the inequalities, this is where it's actually 2 problems in one. Okay, inequalities are actually 2 problems in one. Let's pick one right here. 17, 18, 19, I don't know. Which one? 19. 19, all right. So let's take a look at 19. And the reason why they're 2 problems in one is because an inequality is an area of answers, right? So when you're dealing with an inequality, let's begin with what you see on the inside of the square root. You see 3x plus 3, right? We know that this 3x plus 3, it has to be positive. The 3x plus 3 has to be greater than or equal to 0, because if it's not 0 or bigger, if it's negative, I can't do the square root of a negative. I end up with an imaginary. Does that make sense? So I need to start with this. I need to make sure that I don't have any negatives in there. So I set it greater than or equal to 0, and I solve it, and that'll actually be one answer. Check it out. Minus 3, 3x is greater than or equal to negative 3. Divide both sides by 3. X is greater than or equal to negative 1. Oh yeah, and by the way, since it's an inequality, if you ever divide by a negative, you have to flip the inequality symbol. But because we divided by a positive, you don't have to mess with it, just bring it down. Anyways, this is one answer right here. That's one answer. How do you get the other answer? You go back to your radical inequality and you treat it as a whole, like if it were a radical equation. Okay? So how would we solve this whole thing? First, isolate it. So what's my first step on doing the whole thing? Yeah, getting rid of that minus 2 by going plus 2. And when you do to one side, do to the other side. Now it's isolated. Now I have the 3x plus 3 inside the root, and it is less than 9. And now step 2, you get rid of the radical by applying a power on both sides. What power am I going to apply on both sides? Power of 2. Why am I applying the power of 2 and not 3? Or not 4 or not 5? Yeah, because it's a square root. That's really a 2 right here. So the power of 2 to get rid of the square root. If it were a third root, I'd do the power of 3. Fourth root, power of 4. Anyway, the power of 2 will get rid of that square root. You'll have 3x plus 3 no more root, no more power, is less than 9 squared, that's 81. And now we're going to solve, subtract 3, subtract 3. We're going to end up with 3x is less than 81, take away 3 is 78. Final step, divide by 3, divide by 3. I don't know what 78 do. 26? Thank you. So x is less than 26. So we have our two answers, and we need to think about those answers, and we need to test those answers. Now, since they are inequalities, we're talking about an area of answers. So the best way to really understand what those two answers are is to do a quick sketch on a number line. Let's put the -1 on this side, on the left side. Let's put the 26 way over here on that side. Obviously, 0 would be right here in between the two, right? And if we think about this first one, x is greater than or equal to -1. Greater than or equal to is that way. And if you think about this one, x is less than 26, less than or equal, or just less than 26. It'd be an open dot at 26 going this way. So what our graph tells us is that the answers should be in this area, in between the -1 and the 26. But then again, we've gotten answers before that don't work, right? So we need to actually test. Let's test one of these values and see if it actually works. You could test 3 if you want. How about 0? Let's see how 0 works. If I plug in 0, which is clearly in between, what's 3 times 0? 0. And what's 0 plus 3? 3, okay. It didn't work out that nice, but the square root of 3 is definitely less than the square root of 4, right? Right? So the square root of 3 is definitely less than the square root of 4. It's about 1 point something. So -2 plus 1 point something, that's definitely going to be less than 7. So it does work. Okay. If you pick any other value in here, it should work, right? So like, let's say, I don't know, let's plug in a 7, which is somewhere in here. 3 times 7 is 21. 21 plus 3 is 24. It's almost a square root of 25, so it's almost the answer 5. It's about 4.9. -2 plus 4.9 is definitely less than 7, right? So it is true. All these values in here work. If you test values out here, it will not work. If you plug in anything that's more negative, like -2, -5, -10. If you try -2, plug in a -2 right there, that'll be a -6. -6 plus 3 is -3. That's imaginary. So definitely over here it doesn't work. Try anything over here, like let's say 30. Plug in 3 times 30, that's 90. 90 plus 3 is 93. The square root of 93 is going to be, I don't know what exactly it is, an irrational decimal value, but if you add -2 to it, it's not going to be less than 7. So here it doesn't work. The only area is in between. So because your areas are in between and we've double checked them and it does work, we should write them as a compound inequality with the -1 on the left side, the 26 on the right side, the x in the middle, and with the less than or equal to on the -1, and with the just a less than on the 26. Now why just less than? Because it just had a less than, didn't have an or equal to. It's an open dot. So there's your compound inequality that represents that answer after testing it. I'm sorry, that was a long explanation, but I hope we get it. Anyway, these are great problems to practice. We're going to be doing the even ones. Sorry, we explained odd ones on this video, but we're going to be doing the even ones only. The answers are in the back. You could double check them. It's good practice. However, on the test Friday, yeah, I'm going to pick a couple of these, maybe not from this one or from the other worksheet, but I really like the ones from the book. Check it out. In the book, on page, page 430, I like these examples that they gave because they require multiple steps to get the radical by itself. So you'd have to go +4, divide by 2, and then get rid of the radical. So I would go back, and I already did a video on this before. I'd watch the other videos that explain this example, or you could go back to the book and watch the explanation yourself, or read the explanation yourself. Here's another one that I like also, because not only do you have to get rid of the -6, but you also have to divide by 3. So these are all great examples that might be on the test Friday. Okay, so it's just one more day working on this section. Tomorrow we're going to review the entire chapter. I'm trying to get you a practice test, and on Friday we'll have a test.